Hey everyone, my name's Alex Creeley. I'm the Director of Tokamak Operations here at Commonwealth Fusion Systems, and today we are at the Spark site, and I'm very excited to give you a tour. We've made a lot of progress in the last year, still making a lot more progress, ready to get this machine operating and do some fusion. So if you want to follow me on in, we'll go this way. So, welcome everyone. This is the operations building. So this building will have a lot of scientific instrumentation to measure what's going on inside of the Spark plant. So we call these diagnostics. But basically, in order to measure what's going on inside of a plasma, which is 100 million degrees, you need a little bit more than a thermometer. And so we'll have a bunch of different instrumentation here to measure the temperature of what's going on inside of Spark, the density, how much power we're making, all these kinds of things. We do that for two reasons. One is that we just need to run the plant. So your car has a speedometer on it, so you know how fast you're going. So same reason here, we want to be able to control the facility, control what's going on, run it properly. So we'll have measurements for that. In addition to that, though, we want to learn stuff. So Spark is not yet a full power plant, but it demonstrates the fusion technology. It demonstrates that all this works. So we'll make a bunch of additional measurements on Spark so that we can learn things, so we can improve the design of the ARC fusion power plant, so we can improve its operation, and so we can get to the point where we're ready to build this thing and put fusion watts on the grid. So if you want to follow me, we'll go to the next building. Okay, so before we go in to see the tokamak hall, we'll make a brief pause here and just talk about the tokamak itself a little bit. So if you've seen some of these videos before, you'll probably have heard this, but if not, a brief introduction to what a tokamak is. It's a fusion machine, donut-shaped, mainly made out of magnets. We have a little demonstration here. And these are the big toroidal field coils, TF coils. They're big D-shaped. They go around the pink piece here, which is the fusion plasma. That's the fuel, deuterium and tritium, that we use to do fusion. There's a bunch of other magnets around as well. There's these copper things in the center we call the central solenoid. They look copper. Really, they're also superconducting. And there's these other magnets around here that we call the poloidal field coils that we use to shape and move around the plasma. So all of these magnets, CFS manufactures ourselves, and very soon these will be coming across the street and going into the tokamak hall, which is where we will go next. So if you want to follow me in this way. So we are now in the tokamak hall, which is where the actual Spark tokamak will be built and operated. So as you can see, it's much busier than it was a couple months ago. We have now started the process of assembling the tokamak itself. So the big steel piece there in the middle is the base of the cryostat. That is the bottom of Spark, so everything else will end up getting built on top of that. It has a couple of really important jobs. It keeps the whole machine cold so that the magnets operate, but at the same time, it has to have feed-throughs, which are like basically holes in the bottom to let the coolant in, to have power for the magnets, a bunch of instrumentation. So there's a lot of complexity in like getting all that stuff through properly while keeping the machine cold. So we've started assembly, which is awesome. And very soon, we'll start putting some of the magnets together as well. So these two orange half circles are assembly toolings, like temporary stands where we're going to start putting the magnets together, start putting the vacuum vessel halves into the magnets, and eventually those two will come together in the middle over the top of the cryostat base, and that's where Spark will be in its final position. We'll finish putting the machine together and get ready to start operating this thing. So with that, we'll head out of the tokamak hall and into the next building. So follow me this way. So we are now in the radio frequency heating building. So in order to do fusion, you need your fuel, the hydrogen, really, really hot. By really hot, we mean something like 100 million degrees. And so you need a little bit more than an oven to get it that hot. And so in our case, we use radio waves. It works very similar to how your microwave works at home. In that case, you put your food in, it launches microwaves at the food. The oil and the water absorbs those microwaves and warms up. And we do basically the same thing, but rather than with microwaves, we use radio waves. It's almost FM radio. So FM radio is like roughly 90 megahertz to 108 megahertz. This is 120, so it's not that far off. But rather than launching the waves out to send out music, we launch them in to heat up the fusion plasma. And so those waves we make back here, there's a bunch of those metal cylinders. Those are basically a way of generating radio waves. We make them there. We pipe them through these pipes that you can see at the top. You can think of that like a giant coax cable that you'd normally plug into the back of your internet box. But rather than sending internet, it sends high power radio. And then those come and into the tokamak hull, plug into the side of the tokamak, and launch those waves to heat up the plasma. So with that, we'll head to the next building this way. So we are now in the power building. So in order to operate superconducting magnets, you need to run electricity through them. And this is where we have all the adapters that make them operate. So on your computer, you have that little box in between the outlet and your computer. That's the thing that adapts the power. Same thing this, a little bit bigger. Utility yards outside, that's where we store all of our nitrogen and helium to run the facility. And the really exciting part is we'll get to see the cryogenics here. So we are now in the utility building where we have a lot of the large industrial systems which will keep Spark operating. Most importantly, a lot of the systems in this building take out heat from the machine. We really do that in two ways. One, at really cold temperatures. So to run the superconducting magnets, they need to be really cold. In this context, really cold means like minus 400 Fahrenheit or 15 Kelvin, which is where we operate most of the magnets. What's awesome though is that we're actually starting to operate stuff. So we've got cooling water systems operating. We're starting to operate some of our helium compressors. We're going from just like building stuff to commissioning and operating, which is a really exciting phase of the project and a really exciting step on our path to operating Spark. So with that, follow me to the next building and we'll talk a little bit about next steps. So as CFS gets into the later stages of finishing this plant, commissioning it, starting to operate, and assembling the Spark tokamak, we're also thinking about what's next. We've just announced the site of our first ARC fusion power plant. It'll be in Chesterfield County, Virginia. We have the site picked out. We're really excited about building a power plant there. And we're already doing some of the early engineering design. We're taking all the lessons we've learned from designing this facility, building it, and incorporating that into the ARC design. So we still have a ways to go. We're earlier in the project. We're really excited about getting fusion on the grid and getting that power plant up and running. So thank you so much for coming to visit today. As you can see, we're building stuff, we're operating stuff, and hopefully when you come back next time, we'll be even closer to demonstrating net fusion energy on Spark and closer to beginning construction on the ARC fusion power plant. Thanks for coming.